and drag. Okay, here we go. So we know logs, hi, I'm glad you're here. We know logs and exponentials are inverses of each other. We learned that last time. So we can kind of use that to calculate a logarithm. If we don't have a calculator, then we have to calculate a logarithm a different way. And so let's write down our first example. They are saying calculate this. Like logs are just numbers, just like an exponential to some number, like some base 2. 2 to the 7th power is just some number. Well, log base 2 of 16 is just a number. The question is, what is the number? Like, what does this calculate to be? Now, what we'll do is, if we have to calculate this without a calculator, then what we do is we say, well, we don't know what this is equal to. So I kind of create then an equation. You should be doing this in your notes. I say equals x, because like we don't know what it is, right? We don't know what this calculates to be. And then instead of thinking of this as a log, we don't know how to calculate logs. We do know how to calculate exponentials. Now I would say, okay, let's not deal with logarithms. Let's instead make an exponential function. So in this case, if I don't want log base 2, can I choose to undo log base 2? Yes. With a base 2. So I just choose to rewrite this and it's more like inverse format. So base 2 raised to the log base 2 is an inverse, so they cancel out. So now we're looking at when does 16 equal 2 to what power? Now that we have this equation, it's easier to think about. And we learned last time the 1-to-1, the equality property says if you write both each side as the same base, can't you just solve with the exponents? So remember 16 is 2 to the 4th power. And we have equals 2 to the x. So what's our solution? X equals 4. So we just found out, now if I go back to the original problem, that logarithm calculates to be the number 4. So that's kind of the idea we use to calculate some logarithms. So, and they use the wording, it says use the definition of a logarithm to determine the value. The definition of a logarithm is it's an inverse of an exponential, you know? So that's kind of what we're using here. So let's go again. Let's do number 3. So once again, it just says evaluate. Evaluate means calculate. So you'd say, well, we don't know what it is, so it's x. So then from there, let's not calculate a log. Instead, let's do an exponential. So let's do the inverse. So then base 10 and log base 10 cancel out. So then we're looking for when does 10,000 equal 10 to the x power. So then it's guess and check at this point. 10 to what power is 10,000? I don't know. Let's all go to a calculator and you just start typing in 10 obviously to the first, isn't it? Is it 10 to the second? Nope. 10 to the third? Not quite. 10 to the fourth is finally 10,000. So this is 10 to the 4th equals 10 to the x. So what does x equal? 4. So this logarithm just calculates to be the number 4. So logs are just numbers, you know. It's just now we have to like kind of manipulate this to calculate what a logarithm is. Let's do one with a fraction, number 4. So once again, it says calculate the logarithm. You're like, okay, they want me to do it by hand if they ask me to do it with the definition of a logarithm. So we set it equal to x. We then undo log base 3 with a base 3. Base 3 and log base 3 cancel out. So we have 1 over 81 equals 3 to the x power. Now from here, I do not personally want to deal with fractional bases. I just think it's confusing, personally. So can I rewrite 1 over 81 instead as base 81? Sure. Yeah, what would I have to do though? -1. Yep, make it a negative exponent. This is equivalent to 81 to the -1, isn't it? Because that's 1 over 81. You guys see I brought it up and made it a negative exponent. We usually go the other way, right? But we're trying to get rid of the fraction. So then we have equals base 3 to the x. And then I say I need both to be the same base. 81 can probably be base 3. If you're not sure, go off to the side and break it down all the way. Break it down into its factors. Remember, the word factor means what multiplies to be this. So isn't that 9 times 9? 3 times 3 times 3 times 3. So isn't this base 3 to the 4th? So now rewrite this. This is 3 to the 4th raised to the -1 equals 3 raised to the x. We say when we have a power raised to an additional power, so this is really 3 to the -4 equals 3 to the x. And then from there, we now know x equals -4. So now we know, we go back to the original, we erase what we were doing here, and we say, okay, log base 3 of 1 over 81 calculates to be the number -4. Is this making sense? Okay. And last but not least, we didn't get to an example like this, and then it was on your homework. So let's do this next, number 5 as well. Am I okay to erase this stuff? Anyone need more time looking at this stuff up here? I just need room to write, so I'm kind of erasing all this. Okay, so look at number 5 with me. Once again, same thing. It's like calculate this logarithm. So we set it equal to x. We base 6 both sides. Base 6 raised to the log base 6 undoes. So we're looking for when does 1 equal 6 to the what power? Remember, yeah, you remembered that. Yeah, it's 6. Whoa, how did you guys all know that? You just knew? That's really good, guys. Yeah, you're right. So you're saying that the only way to make this base 6 is to do base 6 to the 0 power, which is 1, right, everyone? So then equals, did we go over that in here? Yeah. Oh, we did? Okay, a different period we didn't. Anyways, x equals 0. So now we know that log base 6 of 1 calculates to be the number of 0. Okay. All right, moving on. So think about this. I would write this down in a minute, but just a minute before you do that. Isn't it true that any base to the 0 power calculates to be 1, everyone? Yep. So 2 to the 0 is 1, 3 to the 0 is 1, 1/5 to the 0 is 1. Okay, well, if that's true then, look, if that's true, then if I start with this and we rewrite it in logarithmic form, we would say, okay, to undo base 2, if I say rewrite this in its logarithmic form, what undoes base 2? Log base 2. Everyone, log base 2. So now log base 2 and base 2 cancel out. So 0 equals log base 2 of 1. So now you know that log base 2 of 1 calculates to be 0. True, everyone? Now let's do 3 to the 0 power. Let's do that. 3 to the 0 power equals 1. Rewrite it in logarithmic form. So everybody, let's do it. What would we do? Log base 3 both sides. Then log base 3 and base 3 cancel out. Doesn't 0 calculate to be log base 3 of 1? So look, we have log base 2 of 1 calculates to be 0. Log base 3 of 1 calculates to be 0. So what's the rule happening here?
Anything that has a 1 is easy.
Yeah, if the 1 is plugged, you're right, exactly. If 1 is plugged into your logarithm, it's going to calculate to be 0 every time. Did you all hear that? See, look, the base doesn't matter. If there's a 1 being plugged in, it's going to calculate to be 0. You can see why, because if you look at the exponential form, it's any base to the 0 power is 1. You know, it's just a backwards process of this. So if we look at this, they're hoping that you'll memorize it. They're saying, so this is a rule you can just remember if you want. So log any base, if you're plugging in 1, is 0. So when you see this in the future and they say calculate, you just say, oh, we could just do this the quick way. Since we're plugging in 1, it comes out to be 0. Plugging in 1, it comes out to be 0. Plugging in 1 comes out to be 0. We just showed you right here. This is exponential form.
No, I mean like, why is 2 to the 0 1?
Because if we have 2 to the 1 over 2 to the 1, for example, what does that divide out to be?
0 or 1.
1. And that's the same thing when you divide, can't you subtract your exponents?
Yeah.
So then we have 2 to the 0. We already know what it calculates to be. Doesn't it calculate to be?
Yeah.
1. So it's because it's really the same thing divided by itself. Okay.
I have a quick question.
Uh-huh.
So are you allowed to have fractions as the base?
Yes.
And logs?
Yeah, think about why isn't decay a base, an exponential base that's a fraction? So you can have a log of that base.
Okay.
Yeah, because decay growth all have logarithmic inverses. Good question. Okay, let's now go to this problem. It says write this in its logarithmic form. It's not asking you to solve anything. It just says rewrite this in its logarithmic form. So right here we have 4 to the x equals 8. I'm going to write it a little bit bigger for my so you guys can see. So if it wants you reading in your instructions, it says rewrite this in logarithmic form. You'd say, well, in this case, then it doesn't want exponential base 4. So I need to undo exponential base 4. So what undoes exponential base 4? Log base 4. So it's just basic algebra here. So now from here, log base 4 and base 4 cancel out. So we have x equals log base 4 of 8. When we take a logarithm, doesn't that stuff then go in the parentheses of our log?
Yes.
Okay, That's it right there, because it just said rewrite it in logarithmic form. We now have a statement in logarithmic form. We don't need to calculate this or anything. It just says rewrite it in logarithmic form. You guys feeling okay? Okay, I think that's what it says. Write an equivalent logarithm form to solve for x. Oh, so they did want us to solve for x. Okay, well, I didn't read the instructions. Very good. Okay, let's now, well, that's kind of a silly way to write that. We did this last time. Okay, let's jump down to number 3. If we have 7 raised to the x plus 1 equals 4, they said rewrite it in logarithmic form to solve for x. So basically, it's just solve for x. We know how to do that, right? Get x by itself. So what do we need to undo? Base 7. How do we undo base 7? So we're going to log base 7 both sides. So on the left-hand side, don't you agree that log base 7 of base 7 cancel out? So now x plus 1 is no longer an exponent. Then on this side, we have log base 7 of 4. Now from there, it says to solve for x. So what would we do now? Good, algebra, and that means we're going to, in this case, subtract 1. So they want x equals log base 7 of 4 minus 1 is x. It's the same idea as finding the inverse, isn't it? Because we just solved for y. You know, we switched x and y, solved for y. In this case, we're doing the exact same thing. Do you guys want to do, let's do just number 5. That's pretty much as advanced as it gets here. It's not super hard or anything. It's just like, it has a lot going on. So it says solve for x. So you'd say, okay, I can solve for x. Isolate the base. Undo the base. So what am I going to apply to both sides? So we're going to do log base 2 to this side and this side. So now on the left, log base 2 and base 2 cancel out. That leaves us with 3x minus 5, no longer in the exponent. On this side, we technically have log base 2 of 20.
Why only technically?
Huh?
Why only technically?
I don't know.
You said we technically have log base.
I don't know why I use that word.
Oh.
I guess I don't know the technical definition of technically.
Okay.
All right, add 5. 3x equals log base 2 of 20 plus 5, yeah?
Divided by.
Divide all of it by 3. And now we've solved for x. X equals log base 2 of 20 plus 5 all over 3. What if this would have came out? So that would be our answer. What if this would have been this? X equals log base 2 of 20 plus 9 all over 3. Could I go like this? 9 and 3 divide out. No, you can't divide across addition signs. Correct, everyone? Or subtraction signs. So that would be not allowed. Are we all feeling okay?
I have another question.
Yeah.
Is that like all we have to do when they ask that, or do they want us to like fully solve it?
You mean fully calculate? Because now that's just a calculation.
Exact x.
So she's asking, should we now get the calculation? Because what's a logarithm? It's a number, right? Everyone, that's just some number added to 5, and then that number is divided by 3. Do you guys see what I'm saying? But we, as of right now, only know how to calculate that log by rewriting it in exponential form, right? That's just feeling like a bit much. I think they're going to accept this answer.
Okay.
Now, if they won't, then what they want is the decimal answer, because this is usually a decimal.
Right.
And we're going to learn how to do that in the future, not today. Not today.
Which would be a bit redundant in this situation anyway, since it's starting with the exponential. You really have to take that solve, right?
Right, you're saying like we could even just solve, if they're saying like, you're saying like, why not just solve that? Well, yeah, I see what you're saying. So you're saying we could just go back to this and solve. Is that what you're saying? Yeah, that's true. If it can be solved by the one-to-one, the equality property, but look, it wouldn't be able to. Is 20 able to be written as base 2?
I mean.
No.
Form, yeah. So it's really the same as a log.
It's not able to be written as just base 2 though, right? So we actually have to solve with logarithms on this one. So actually, if they say solve, we couldn't use the one-to-one property, the equality property. We have to get this answer. And this does calculate to be a decimal, but we have not learned how to put this into a calculator yet. It's has a little more to it. I don't think we need, I think they're accepting this answer.
Okay.
Okay. Great question. All right. So read this with me. I need you to just kind of read this with me and then start with writing down some notes of what I'm writing. It says create a table showing logarithmic growth of base 3. So this is what you're going to say to yourself. Okay, if it's logarithmic growth of base 3, logs and exponentials go hand in hand, true? The only way to get logarithm points is to actually first get exponential points, right? And then we just switch them. Aren't they inverses of each other? That's not the only way. That's the easy way. So say, I'm not going to start with a logarithm. Logarithms are hard to calculate. Instead, let's start with an exponential. The base is, so rewrite it. We have 3 to the x power. This is a lot easier for our brains to calculate. So we always, with logarithms, if we're asked to create a chart for points of our logarithm, we want to actually just start with the exponential. So let's do -2, -1, 0, 1, and 2. 3 to the -2 calculates to be what number? 1/9. 3 to the -1. 3 to the 0. 3, and then 3 to the 1 is 3, 3 to the second is 9. Now, if you type that in, you're giving me exponential growth of base 3, which is close, but it wants the log growth of 3. So don't we just switch? It just says saying, what are the inverses? What's the inverse of this? So you'd say, well, I just switch my x, y points.
Seems like they're really interested in inverses this year.
1/9, yeah, they are. 1/9 -2, 1/3 -1, 1, 0, 3, 1, 9, 2. These are your logarithm points, and that's what it wanted. This is logarithmic growth of base 3. It's just flipped on its side. Isn't it an exponential flipped on its side?
So on the test, what if I just like make the original table and then erase x and y and switch them?
And then you're just saying go like this. Like if you just made this and went, this is x, this is y.
Yeah.
That's fine.
Yay.
Okay, so now we're going to learn how to graph a logarithm, everyone. So we just did it. Like literally that's how we graph logarithms. We first start with the exponential instead. We switch the points. Boom, there's your points. You know what I mean? Graphing the log is super easy. So like right here, if I ask you to graph this, let me show you what we do. You'd say, okay, they're asking me to graph this. I need an XY chart for this. Calculating a logarithm is hard. It's annoying. So I'm like, I'm not going to do that. Instead, I'm going to do the inverse. What's the inverse of log base 2? Base 2, right, everyone? The bases go hand in hand. You guys agree? It's exponential base 2. So I'm not even going to overcomplicate it. It's simply base 2, isn't it? So then I make an XY chart for that. So I'm going to do -2, -1, 0, 1, and 2. What's 2 to the -2? 2 to the -1. 2 to the 0. 2, 4. Then don't graph those because we're not graphing exponentials. It said graph the log, but now I just take those points and flip them. So I'm going to graph 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2. Now I've already graphed it for quickness purposes. So look, over 1/4, down 2 units. Do you guys see? Over 1/2, down 1 unit. Over 1 up 0. Over 2 up 1. Over 4 up 2. And then I connected the dots. So graphing a log is not hard, is it? You put the exponential and you switch the points and whoop, there it is. Now, if it's a parent function of a log, now look at it, it is. There's no shifts. It always has a vertical asymptote at 0. Think about why. Because if it's exponential growth, it has a horizontal asymptote at 0. Aren't we switching x and y? So you're saying, if this is on x, now it's on y. So just remember that. If it's a logarithm, it has a vertical asymptote at 0. If it's exponential, horizontal asymptote at 0. Just one's this way and one's this way. All right, so now it asks, notice on this logarithm, the domain is not -infinity to infinity. What is our domain?
It's 0.
0 to infinity, isn't it? Isn't it getting close to 0 but never going over that asymptote? True? So it never actually reaches 0. So that's why I put a parenthesis here. The range, though, isn't it going down and up forever?
Yeah.
So your range is -infinity to infinity. It asks, what's the vertical asymptote? The vertical asymptote is at x equals 0. Not y equals 0. Now it's x equals 0. You guys feeling okay about that?
Actually, my throat's been so much.
It is? I'm so sorry.
I have a question.
Oh, yes, yes.
So with the domain and range,
Uh-huh.
you just literally swap the domain and range from your exponential
Exactly. Yep, and we know that the domain for an exponential is negative infinity to infinity, so it must be this is range. Do you guys see what she's saying? And then we know our range for the exponential is 0 to infinity, which must be our logarithm's domain. She makes a great point. So whatever's easiest for you to think about, do that. All right, now look at this one. They now are saying here is a log that's been shifted. Shifting for all functions works the same. So look at the equation and verbally tell me what is the shift. So I'm going to write that. Left 8 units is what happened here. And it says, what was the parent function? That means just take off the shift. Yep, log base 2 of x, right, everyone? And then it says, okay, now look at the graph. Our new asymptote is at negative 8. That makes sense. Didn't it start, look, doesn't it always start at 0? For all parent functions? Don't all parent functions of exponentials start at 0? Yeah. Then all logarithms parent functions start at 0. But think about it. If you shift it up and down, that asymptote just stays in place. A logarithm, if you shift left and right, doesn't the asymptote change? So we know with exponentials, it's backwards of that. Think about it. If we have a horizontal asymptote, a shift left and right doesn't change. What changes? A shift up and down. So the inverse thing's happening for your log. So everyone notice now it's left 8. So the asymptote's at negative 8. This is really helpful because a lot of times they'll just say, what's the asymptote? It's always your shift left and right. Do you guys see what I'm saying? If they ask you what's the asymptote on your exponential, it's always the shift up and down. So it should be really easy, but it is easy to get these backwards if you don't study hard for the test. Kids just get it all mixed up. So now the domain is 8 to infinity, isn't it? Oh, no, it's not. It's negative 8 to infinity, isn't it? But our range for all logarithms is always negative infinity to infinity. You guys can see the negative 8 to infinity for a domain.
It would be negative 8 though if you had a coefficient, right?
So if you have a coefficient, doesn't that only affect our y values?
Oh yeah.
And so if you take your asymptote and times it by some number, it still is just the same asymptote. Because it's like a factor. Oh, but and it wouldn't even get times to it. Isn't this an x value? Mm-hmm. Don't stretch and compressions only go to y values? So that's why the asymptote wouldn't change. Okay. Yeah. All right, so right here, literally they're just going to ask on the homework, where is the vertical asymptote? So it's your shift left and right. So what is it? Isn't it right 3? So you'd say it's at x equals 3. Everybody good? All right, right here, you would say, okay, what's the shift left and right? Left 7. So that's your new asymptote. You'd say x equals negative 7. See how easy that is? You guys feeling okay about that? Okay. All right, so from start to end, they're going to say, use the table of values you created to graph log base 3 of x. Have we already done that or something? We did? Oh, we did the chart for it back up here. So we're now graphing those points. So help me remember them if you don't mind.
You just drag it down.
You can?
Yeah, zoom out, drag it, and then drag it down. With the circle tool.
Oh, like this. Let's see if Noah's right. Oh, whoa. I can't use my... Okay, let's see. You're saying go like this. Holy shnikes. You're like the coolest cat I know.
Mr. Durbridge was very good at this whiteboard.
Wow, yeah. I'm glad you had Mr. Durbridge. All right, so now we're plotting these points. That is super cool, actually. So we go over a ninth, down 2 units. I'm going to do it in pink. Over a ninth, down 2 units. Over a third, down 1 unit. Over 1, up 0. Over 3, up 1. Over 9, up 2. That is what a logarithm looks like. Isn't it an exponential on its side? So it looks good. Don't be that person that does this on the test. That's wrong. You would say, because it's base 3 raised to the, so it's base 3 to the x, which then we switched our points, right, everyone? There's no shifts on our logarithm. We look at the logarithm. We're graphing the logarithm. So it has a vertical asymptote at 0. This is a parent function for a log. So then from there, that helps you make sure when you finish that you don't accidentally cross that. And then it once again says, so what's the domain? You'd say 0 to infinity, wouldn't you? The range is negative infinity to infinity. And our x-intercepts, it just says, what is your x-intercept? It should slap you in the face. Isn't it when x equals 0?
So what? That looks like a y.
When I said x equals 0, that doesn't make sense. Look, at an x-intercept, it's a y value of 0. right? My bad. I didn't mean to say that backwards. Our vertical asymptote is at x equals 0. Okay, so that's the end of 6.1. I think we should move on to 6.2 because now it's just shifting a logarithm, which we know how shifting works. Would you guys agree, or would you rather not learn 2 lessons today? We have to learn 2 lessons a couple times, so I feel like it's just like we're playing it by ear.
Well, let's learn 2 lessons today.
Okay, sounds good. 6.2. So a parent function has this form. Log base b, the base can be anything. That's what creates your growth factor or decay factor. That's just what creates how steep it grows or decays. And then of x, this will be what the parent function looks like. And our vertical asymptote for all parent functions of logarithms are always at 0. So I've just written that in that top part. We just saw that. Let's start writing down the shift. Right here, we're writing down this. A shifted logarithm looks like this. It could have an a value in front. We know that's a vertical stretch or compression. And we know that affects our y values. What's nice is this is the same all year. Like shifts don't change no matter what type of function we're dealing with. Then we know shifts left and right are grouped in with x. We go opposite of the sign. That will affect our x values. So to take your x values and fix them, we'll take x and add h, or take x and subtract h. And we talked about it in our last lesson. That's also our new horizontal, not horizontal, did I write? Okay, new vertical asymptote. You shift left and right your new asymptote. We went over that in the last lesson. Okay. Then plus k is added on the outside. That's a shift up and down. The sign stays the same. That goes with our y values. So to fix your y values from your parent function, you'll add k or subtract k. Now, if you have 2 shifts for y, then you have to do it in the correct order. Remember, a is a shift for y and plus k. So you have to multiply by a first and then add k. Nothing new to us.
Oh, so we're not going to have a coefficient for x?
No, never.
Yay.
Not in 1010.
Oh,
Okay,
Do we do it in 1050?
we do. It's not hard though.
Okay.
I know.
All right, so everybody, a negative in front with a, remember, is considered a reflection over the x-axis. We have to remember our reflections. A reflection over the x-axis gets fixed not to your x's. You take your y's and times them by -1. So just reviewing stuff we already know. Remember, if the negative is inside, in front, with x, like grouped in the parentheses with your x, this is considered a reflection over the y-axis. And to fix your values, if you have a table of values from your parent function, you'll take your x's and times them by -1. So we just got to be really good at this parent function business.
So that's the coefficient that we will have.
Yeah, in the future, in 1050, there could be like a 2 in front of x in the parentheses, but we're not going to talk about that today. Okay, so let's read this problem. It just says, write the equation of this transformation. It says, this is your parent function, shift vertically up by 7. So what would be the new equation?
Log base 3 of x plus 7.
Log base 3 of x plus 7, right, everyone? And then when you're going to the homework, they might make you type in f of x equals, you know? Just to be like technical. It says, okay, this is shifted down by 4. So what would we say? Log base 7 of x minus 4. It says, what was the transformation made here?
Plus 9.
Up 9. What was the transformation made here? Down 3. You're right. Very good. And moving on. Right here it says, okay, write the equation if it's shifted right by 2. Here's our parent function. So we'll say log base 3 of?
X minus 2.
Good. It's just left and right we do opposite. You get the picture with that one. And then right here it says, what's the transformation? Left 3. What's the transformation? Right 8. Aren't those our new asymptote?
Yes.
Always. It really always will be. Okay, very good, very good. And then now it just says, okay, what is the transformation if it's shifted down by 3 units and right by 2? Now they're just putting 2 of them on. So you'll say f of x equals log base 3 of? X minus 2 is right 2. Down by 3 minus 3. This is all pretty easy, right? Okay, moving on. It says what is, let's do just this one. What is the shift?
Left 5.
Left 5? Down 4. Those are going to go super quick on the homework. Okay, now it says right here, write the equation if it's stretched by a factor of 7. We know that's multiplied in front. This will be just 7 log base 3 of x. Do you guys see how stretch and compressions look? So right here it says, what is the transformation?
Pressed by a factor
Yep, compressed by 1/6. Very good. Moving on.
Wait, but Ms. Bowman, I thought if you said compressed by a factor of 6, I mean, 1/6 is already saying it's compressed. That's like saying a double negative. Because you're compressing by a factor of 6.
Oh, really? They want you to write 1/6.
Oh, really?
They even can interchange this word for stretch.
Because on the homework, they did do that.
On the
What?
homework
So
it's-
like, if,
No way.
yeah,
Yeah.
so on the homework, if it says it's compression, if you put in 1/6, it's wrong.
No
You
way.
have to
Yeah.
put 6.
Seriously, I never knew that. I always thought they wanted 1/6 because they can interchange the word stretch and
That's why I
compression.
was so
Yeah, if
frustrated on the
it's a
homework. 'Cause
stretch,
they
then it
did.
would be of 1/6.
Oh dear, it's all in the wording. Okay, whoa, I have never had 1010 be that. They're like trying to be tricky, to be annoying.
Yeah.
So you're saying if they use the word stretch, then you have to put 1/6.
Yeah, but if it's
Oh.
compression, it's 6.
Never, ever, ever have I seen that, but it makes sense. Like you were saying, a double negative.
Uh-huh.
Okay, but no, we don't write that. You're saying it compresses by 6.
Yeah.
Yeah.
My bad, my bad.
Oh.
Okay, good to know. All right, looking at this one, it says, what is the transformation? Let's just verbalize it. Stretch 3, left 5, up 7. If they said, where's your vertical asymptote?
Why equals 5?
X equals -5, right, everyone? Easy stuff.
How did you confuse somebody?
All right, right here, what's the transformation?
Reflection over the x-axis.
Okay, reflect over the x-axis. Stretch 3. Whoa. They didn't use parentheses, and that threw me for a weird loop.
Oh, yeah.
But there's no such thing as just log base 2, so it has to be, they sometimes lazily don't put parentheses on there. You're right, and then that's a reflection
Well, if they
over
don't
the
put-
y-axis.
If they don't put parentheses, couldn't we say it's log base 2 of 1? Because there's no parentheses there?
So if it like really was of 1, there would for sure be parentheses around it. All right, let's graph this. In your notes, you need to write this down. I'm telling you, I don't know, like there will for sure be one on the test. And so many people miss it, and it kills me because these should not be super hard. But it's a lot of steps, so I can see why people get it confused if they don't study. So it says graph. So listen to the process. You've got to just memorize this process. And this is just my opinion that this is the easiest way to do this. So what I do is I take off all the shifts from the log. So what would be the parent function?
Log base 2 of x.
So that's what I start with. And then I say I need an XY set of points for that. Because then can't we just shift them?
So switch it to an exponential.
Exactly, but I don't want to calculate logarithm points. That's confusing. So instead I switch to exponential form for a minute. So I say I need to get some points for this because it's easier to think about. Let's plug in -2, -1, 0, 1, and 2. So it's obviously 1/4,
1/2,
1/2,
2,
1, 2, 4. Now what happens is a huge chunk of students on the test then transform those points. And then they graph it. They almost have it right, but they've transformed the exponential function, right? This is not a transformation of an exponential function. It's a transformation of a log. So you need to first actually get your log points, which is easy. We need to swap them. You guys see? You can see why a lot of kids will do that. Like, seriously, a big chunk of kids do that. I'm still worried that they will, even though we've talked about it. Now that these are our log points, we can now apply the transformation. When we have a -3 in front, does it go to x's or y's? So take your y's, times them by -3. I'm showing my work here.
then subtracts. Oh, you didn't have to.
I'll just write it out. Might as well, I feel like. Then right here, you're saying down 6.
Yeah.
So then that goes to our y's, so then we'll be minusing 6. I'm just writing the equation of what happened. So then I'll minus 6, minus 6, minus 6, minus 6, minus 6, minus 6. All right, then let's do our x's, and then we can just start calculating. Isn't it left 3?
Yeah.
So we're going to say x minus 3. So we'll take our x's and minus 3, minus 3, minus 3, minus 3, minus 3, minus 3. I'm going to zoom in if you don't mind, so I don't mess up. Let's do our, in green here, 1/4 minus 3. I like decimals for graphing. That's just me. So if I don't, that one I can tell what it is, but like, you guys understand you can take your calculator and find the decimal, right? Yeah, negative 2.75, like you were saying. Negative 2.75. Won't this be negative 2.5?
Yeah.
This will be negative 2,
-1,
negative 1,
1.
and 1. Now I just got to be extra careful here. Got to be really careful. Isn't that positive 6?
Yeah, so 0.
6 minus 6 is 0. Positive 3 minus 6.
-3.
0 minus 6.
-6.
Negative 3 minus 6.
-9.
Negative 6 minus 6 more. Negative 12. Then before I graph, it is always recommended to first draw in your asymptote so you can know if something went horribly wrong, because your point should approach your asymptote and not cross it. So we know for logarithms, it'll be at your shift left and right. Isn't it left 3?
Yeah.
So it's at x equals negative 3. I go put that in real quick. Then I just plot points. Like now I'm just literally plotting points. So I'm at negative 2.75. That's close to the asymptote of 0. So I feel good so far. Negative 2.5 up. Nope, down 3. 2.5 down 1, 2, 3. Not drawn to scale. Negative 2 down 6. Negative 1 down 9. Over 1 down 12. Is it creating an exponential looking function?
Yeah.
Connect the dots, isn't it? It's just super stretched out, you know? And there's your logarithmic graph. We're done. That should not be one we miss on the test. There's going to be at least 10 of you who drop the ball on that. At least. So don't be the statistic.
Why'd you point at me first, Miss Bowman?
Because you're always the statistic. I'm kidding. Let me point something out to you guys. This can trick people because they go, well, we don't know if the plus 7 is in the parentheses with the log or not. Can you agree that can seem confusing?
So if they don't have parentheses, it's that it's outside.
Yeah, for sure. If they wanted that plus 7 to be a shift left and right, they would put parentheses around it. So we're assuming that this is the only thing in the parentheses. Okay, so we're good there. It just says, what's the transformation? We've practiced plenty of that. Would you agree?
Yeah.
All right. Do you guys need to see another log graph, or do you feel okay about graphing a log? You write down the parent function. You then do the exponential parent function, right? Get the points and do what with them? Switch them, and then do the transformation of those points. Okay, I'm willing to do more if you feel like you need more. And then it just says, okay, write the equation. I'm only going to do one of these. Let's do number 2. It says, write the equation if it's reflected across the y-axis. So you have to ask yourself, reflected over the y, does the negative go outside or inside the parentheses? Outside. So you'd say negative so far, log base 7 of x, yeah? That just is the reflection across the y. Compressed half its height. So won't it be negative 1/2 log base 7 of x, yeah? Shifted up by 7, yeah? And then it says, what's the equation of the transformation? Then it asks, what's your vertical asymptote? You'll say it's the shift left and right. 0. That's the end of the lesson.
Let's do another lesson.
No, so a reflection over the, oh wait. No. So this, a reflection over the, awkward. We need to actually think that again. You're saying a reflection across the y-axis affects x's. If I put it out here, isn't this what affects y's?
Yeah.
Oh dear. So you're right. That's not good. So I would have missed points on my test. I got to put the negative in here.
Wait, so in logs, y-axis, like across the y-axis is inside the parentheses.
Correct. Which can be confusing. Because when I saw y-axis, my brain went y's, and that's on the outside. But we know a reflection over the y-axis doesn't affect y's, it affects x's.
Okay,
Miss Bowman.
Kind of interesting.
so x-axis is outside.
Yes.
The okay.
Yeah, and it is tricky. Like, we memorize it up here, but that's the hardest one even for me, as you can see, to remember.
Yeah.
And Miss Bowman, the negative will never affect the asymptote.